Welcome to the combination notes video. First, I want you to come up here to the top, make sure you filled in your name and your hour, which means you need a pencil. And then as you can see on the left, we're going to be using a calculator today. I'll be using a calculator for some of the problems. You don't necessarily have to have it. We're going to be talking about two things. The first one is a combination. It is where your order doesn't matter. So, for example, the first one wants us to pick an outfit from 4 shirts, 3 pairs of pants, and 2 pairs of socks. So I'm going to go ahead and draw 4 shirts. You do not need to draw this with me. It just makes it a little easier to explain the problem. Okay, so you've got your 4 shirts. And then each shirt, you could pick any of the pairs of pants. So you could pick this pair of pants, this pair of pants, or this pair of pants. And then the same thing. Pants, pants, pants. And I'm going to go ahead and just do it for these first two. I would have to do the same thing for the other two as well. It's just going to get really tiring drawing the whole thing. And then you have 2 pairs of socks for each one. So I could pick this pair of socks or this pair of socks. This pair of socks or this pair of socks. And as you can imagine, like, this is going to give me a bunch of options for each one. I know my socks look gorgeous. Okay, so I'm just going to do this for the very first shirt and say, hey, this is going to be the same thing for the other 3. So basically, I end up with 1, 2, 3, 4, 5, 6 options. Because if I pick this pair of pants right here, I get these 2 options. If I pick this pair of pants, I could pick either of these. If I pick this pair of pants, I could pick either of these. So that's 6 different possibilities. Well, I have to do that 4 times because there's 4 different shirts. So 6 times 4 gives me 24 possibilities. Now, here's the deal. I've got 24 outfits. I kind of just showed it by drawing it all out. The shortcut is you're going to take all 4 shirts and multiply it by 3 pants because you could pick any of the pairs of pants for all of the 4 shirts. Then for each of those possibilities, you have to multiply it by 2 because there's 2 pairs of socks you could pick from. So you just multiply these 3 numbers together, and that gives you 24. So if order does not matter, you just multiply those 3 numbers together, and that's it. Now, a permutation is what happens if order does matter. So, for example, there are 8 runners in a race. How many possible ways are there for them to get first, second, and third? Okay. So here is basically what's going on. I'm going to label my 8 runners A, B, C, D, E, F, G, and H. If I just randomly pick a person, let's say C goes first. So I have 8 options for the first place person. And if I make that person C, now how many runners are left to go second? Only 7. The same person can't get first and second. And let's say person F gets that one. Then how many runners do I have left to get third place? 1, 2, 3, 4, 5, 6. Okay, so basically what's going on here is you have to ask yourself, how many positions do you have to fill? First, second, and third. And then you have 8 choices for the first one because there's 8 runners. But then you've used a runner, so you only have 7 runners left for the second one. And then you've used 2 runners already for first and second, so you only have 6 runners left for the third one. So I need to do 8 times 7 times 6. 336. So there are 336 possible ways in which you could arrange those 8 runners into first, second, and third. So when order matters, this number is always going to go down by 1 each time. And however many you have to start with is what goes first. Then I only went out 3 places because it only asks me for first, second, and third. And we'll talk more about these as we practice over here on the right side. But basically what we have to do now is decide, does order matter or not? Because if order doesn't matter, that's a combination. And if order does matter, it's a permutation. So I'm going to go ahead and read the first example. You roll 2 6-sided dice. How many different rolls are possible? These are 2 completely separate things. Order doesn't matter. The roll that you get is the same whether you rolled one first or the other one first. So this one's going to be a combination. And there are 6 numbers on a die. 1, 2, 3, 4, 5, and 6. So you have 6 possibilities for the first die times 6 possibilities for the second one. And what's 6 times 6? 36. So there are 36 possible rolls. Alright, next one. A store owner has 8 bestsellers to pick from to display on 3 book stands. How many different ways can she display them? On this one, order matters because the order in which she displays them makes a difference. So it's kind of like the one where we had first, second, and third place. This one's a permutation because it matters. So she's basically got a display with 3 book stands. Here's one, and here's one. And if she has 8 bestsellers to pick from, that means she has 8 books for the first spot on the left. But once she's picked that spot, she only has 7 left for the next one. And once she's picked those 2, she only has 6 left for the third one. And then we're going to multiply those all together. 8 times 7 times 6. That's actually the one we already did. If you look over here on the left, we already did 8 times 7 times 6. So there are 336 ways that this bookstore owner can display her books. So realize that was 2 problems, but they were really asking you to do the same math. Okay, third one. Cindy's organizing her blue, red, green, and floral scarves on hangers. How many different ways can she organize them? So we're assuming that she's putting them in an order as she hangs them up. So that is going to be a permutation. Now she has 1, 2, 3, 4 different scarves. So she's going to need 4 different hangers. I know those are terrible drawings of hangers, guys. Sorry. To hang them on. Which means she has 4 scarf options to pick for the first one. 3 scarves left to pick from for the second one. 2 scarves left to pick from for the third one. And just 1 spot left to pick from for the last one. So we just have to multiply 4 times 3 times 2 times 1. 24. So there are 24 ways she can organize these. All right, fourth one. A deli offers 3 bread options, 5 meat options, and 4 chip options. How many different sandwich options are possible? This one is kind of like the outfits one, where you just need to be able to pick a bread, a meat, and a chip. Whenever it's 4 completely separate things like this, bread, meat, chips, that's going to be a combination, because you're just trying to make a combination of the 3 of them. Order doesn't matter because the person's still going to make your sandwich out of the ones you pick, okay? So a combination is where you just multiply the number of options for each one together. So 3 bread options times 5 meat options times 4 chip options. 3 times 5 times 4 is 60. So there are 60 different sandwiches. All right, last two. You spin a spinner with 5 sections 3 times. How many different results are possible? This one is kind of like the two-sided dice one at the top, where order doesn't matter. Because you can respin the same thing again. Like if you spin a spinner, it could lean on the same thing twice. So you've pretty much got 5 options because there's 5 sections for the first spin, 5 options for the second spin, and 5 options for the third spin. So 5 times 5 times 5, 125. Results. And the last one, know about a clock and needs to create a 3-digit code, but doesn't want to use the same digit twice. How many codes are possible? So when you're typing in a code, it 100% matters what order you type the numbers in. So this is a permutation because order matters. Then I'm just going to multiply. If you're looking at a lock code with digits, you have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different numbers. So if you're trying to create a 3-digit code, you have 10 numbers for the first spot, but then he doesn't want to use the same number twice, so he only has 9 numbers left for the second one, and then he only has 8 numbers left for the third one. So 10 times 9 times 8 is 720 different codes. And this is why it's so hard to break codes and why people have things like locker combinations, because it's really hard to guess through all 720 options. Okay, before I let you guys go to the assignment, I just want to recap that when you are doing a permutation, this one, that number goes down once every time you move to the right. And you only do as many spaces that it asks you for. So this one asked me for first, second, and third place. So I did this 3 times. But this one, this hangers one, I had to do all 4 because I'm hanging up all 4 scarves. This one, there were 3 book stands, so I only needed 3 numbers. And the last one, it was a 3-digit code, so I only needed 3 different numbers, but I started with 10 of them. Then combinations just mean how many different ways can you combine the 2 things. So that's like rolling 2 dice because the order doesn't matter. It's if you're trying to make something that has different options, like bread, meat, and chips. Or if you have 2 things, or if you have something like spinning a spinner that resets each time.